Have you ever wondered why a company like ChatGPT can go from 0 to 100 million users in just 2 months, while it took Netflix 15 years to reach the same milestone? Or why Instagram was acquired for $1 billion when they only had 13 employees? The answer lies in understanding something that's fundamentally reshaping the business world. Artificial intelligence companies scale in ways that traditional businesses simply cannot. Let me explain what I mean by scaling. When we talk about a business scaling, we're talking about its ability to grow revenue dramatically without having to proportionally increase costs. A traditional restaurant, for example, can't really scale. If you want to serve twice as many customers, you need roughly twice as many tables, twice as many chefs, twice as much food, twice as much space. Your costs grow almost linearly with your revenue. But AI businesses, they operate under completely different rules. The fundamental reason AI businesses scale so fast comes down to what economists call marginal cost, which is the cost of serving one additional customer. For most traditional businesses, this marginal cost is significant. If you're making physical products, every new item you manufacture requires materials, labor, shipping, and storage. If you're providing a service, every new customer requires more of your time or more employees. But with AI, the marginal cost approaches zero. Once you've built the AI model, serving the millionth customer costs essentially the same as serving the 10th customer. Think about it this way. OpenAI spent enormous amounts of money training GPT-4. We're talking hundreds of millions of dollars in computing power, data, and talent. But once that model exists, whether 10 people use it or 10 million people use it, the incremental cost per user is incredibly small. Yes, there are server costs and computational expenses, but these pale in comparison to the value each user receives. This is why AI companies can afford to offer free tiers that would bankrupt traditional businesses. They're not losing much money on each free user, because each free user costs them almost nothing to serve. But there's something even more powerful happening with AI businesses that makes them scale faster than even traditional software companies. And it's this concept of network effects combined with data feedback loops. Every user who interacts with an AI product is actually making that product better for everyone else. When you use Google Maps and it learns from your route choices, when you talk to ChatGPT and it learns from those interactions, when you watch videos on YouTube and the recommendation algorithm gets smarter, you're not just consuming a product, you're improving it. This creates a virtuous cycle where more users lead to better products, which attract more users, which make the product even better. Let me give you a concrete example. When Tesla's autopilot system makes a mistake or encounters a novel situation, that data gets fed back into the system. Every Tesla on the road is essentially a data collection vehicle, and with millions of miles driven daily, the AI is learning from an incomprehensibly vast dataset. A traditional car manufacturer would need to do expensive testing with paid drivers to gather this kind of data. Tesla gets it for free while providing value to customers. The more Teslas on the road, the smarter the system gets. The smarter the system gets, the more valuable Teslas become. See how that works? Now let's talk about something that really sets AI businesses apart: automation of what used to require human intelligence. Traditional businesses hit growth limits because they need to hire more people. Customer service, content creation, data analysis, decision-making. These all required humans, and humans are expensive and take time to train. AI businesses are automating these bottlenecks. A chatbot can handle customer inquiries 24/7 without getting tired, without needing health insurance, without taking vacations. An AI content moderation system can review millions of posts per day. An AI recommendation engine can personalize experiences for billions of users simultaneously. This isn't just about cost savings, although that's huge. It's about removing the physical and temporal constraints that have always limited business growth. A traditional consulting firm can only grow as fast as it can hire and train talented consultants. An AI-powered analytics platform can onboard thousands of new clients in a day without adding a single employee. The traditional firm's growth is linear, bounded by human availability. The AI company's growth is exponential, bounded only by market demand and server capacity. But here's where it gets really interesting. AI businesses benefit from what I call compounding advantages. In traditional industries, being twice as big as your competitor might give you some economies of scale. Maybe you can negotiate better supplier prices or spread fixed costs over more units, but the advantage is modest. In AI, being twice as big often means you're exponentially more powerful. You have more data, which means better models, which attract more users, which generate more data. You can afford more compute power, which means you can train larger models, which perform better, which brings in more revenue, which allows even more compute power. Look at what happened with large language models. When GPT-2 came out, it was impressive but limited. GPT-3 was dramatically better, not because the underlying architecture changed radically, but because it was bigger and trained on more data. GPT-4 represented another massive leap, again largely through scale. The companies that can afford to train these massive models pull further and further ahead of smaller competitors. This creates natural monopoly tendencies in AI markets. The winner doesn't just win, they often dominate completely. There's also the speed factor. Traditional businesses are constrained by physical reality. If you want to open a new retail location, you need to find real estate, negotiate leases, build out the space, hire staff, stock inventory. This takes months or years. If you want to launch your AI product in a new country, you can literally do it with the flip of a switch. Translation models can localize your product instantly. Cloud infrastructure means you don't need to build physical data centers in every region. Regulatory compliance is still a factor, but the technical barriers to global expansion are minimal. This speed extends to product iteration too. Traditional products require manufacturing retooling, supply chain coordination, quality testing. Updating an AI model can happen continuously. A/B testing with AI products is trivial compared to physical products. You can run thousands of experiments simultaneously, learning what works and what doesn't at a pace that would be impossible in traditional industries. Companies like Netflix and Spotify are constantly tweaking their recommendation algorithms based on real-time data. They're essentially rebuilding their core product daily, something a traditional media company could never do. Let me address something crucial here: the role of venture capital and investor expectations. AI businesses can scale fast partly because investors are willing to fund massive losses in pursuit of exponential growth. This isn't unique to AI. We saw it with social media and other internet companies, but AI amplifies it. Investors understand that in a market with network effects and compounding advantages, being first to scale can mean capturing the entire market. So they're willing to pour billions into companies that aren't profitable, betting that once these companies reach scale, they'll achieve monopoly-like dominance. This creates a self-fulfilling prophecy. Because investors are willing to fund aggressive growth, AI companies can offer products at below cost or even free, rapidly acquiring users in ways traditional businesses never could. Those users generate data and network effects, which make the product more valuable, which attracts more investment, which funds even more aggressive expansion. It's a flywheel that traditional businesses simply can't spin at the same speed. Now, there's a darker side to this rapid scaling that we need to acknowledge. When businesses grow this fast, they often outpace their ability to handle the consequences. We've seen AI products deployed at massive scale before anyone fully understood their societal impacts. Facebook's newsfeed algorithm was optimized for engagement, and by the time anyone realized this was promoting divisive content and misinformation, billions of people were already using it daily. The speed of scaling meant the speed of impact, both good and bad, was unprecedented. There's also the question of what happens to labor markets when AI businesses scale so efficiently. Instagram was bought for $1 billion with 13 employees. WhatsApp was acquired for $19 billion with 55 employees. These companies created immense value, but very few jobs relative to traditional companies of similar market capitalization. A car manufacturer worth the same amount might employ hundreds of thousands of people. This efficiency is exactly why AI businesses scale so fast, but it raises profound questions about wealth distribution and employment in an AI-driven economy. Let's talk about defensibility for a moment, because this is crucial to understanding why investors value AI businesses so highly. Traditional businesses build moats through brand loyalty, patents, regulatory capture, or physical infrastructure. AI businesses have all of these plus data moats. The more data you have, the better your AI performs, and the better your AI performs, the more users you attract, and the more users you attract, the more data you collect. This moat gets wider over time, making it increasingly difficult for competitors to catch up. Consider Google's search engine. Even if a competitor had the same algorithm, they wouldn't have decades of search data to train on. They wouldn't have billions of users providing implicit feedback on result quality. This data advantage is so powerful that despite numerous well-funded attempts to compete with Google, no one has succeeded in significantly denting their search market share. The same dynamic plays out in social media, e-commerce recommendations, voice assistants, everywhere that AI and data combine. But here's something fascinating. AI businesses can also scale by enabling other businesses to scale. Amazon Web Services, Google Cloud, Microsoft Azure, these platforms provide AI tools that let other companies move faster and scale more efficiently than they could on their own. A startup that would have needed a team of data scientists can now plug into pre-trained models and sophisticated AI tools for a fraction of the cost. This creates an ecosystem effect, where the scaling of AI infrastructure companies enables the scaling of thousands of other companies. The talent dynamics are interesting too. Traditional businesses needed large workforces, which meant they were limited by labor markets in their geography. AI businesses can hire the best talent globally, with remote work being more feasible for knowledge work. More importantly, each engineer or data scientist at an AI company can have massively leveraged impact. One person building an AI model might create something that serves millions of users. This attracts top talent because the potential impact is so much greater than in traditional industries, and that talent concentration further accelerates growth. There's also something to be said about how AI reduces the importance of industry-specific knowledge. Traditional businesses, in healthcare, finance, logistics, they all required deep domain expertise that took years to develop. AI is changing this. A talented AI team can enter an industry, apply machine learning to existing data, and often outperform incumbents who have decades of experience. This lowers barriers to entry in established industries and enables faster disruption. Let me give you an example. In medical diagnosis, AI models trained on millions of images can now match or exceed human radiologists in detecting certain conditions. The AI doesn't need to go to medical school or do a residency. It learns from data. This means a tech company can enter healthcare and scale rapidly in ways that would have been impossible before. The same pattern is playing out in legal services, financial analysis, customer service, and countless other fields. The global nature of AI scaling is worth emphasizing. A traditional restaurant chain might take decades to expand internationally, dealing with different cuisines, regulations, real estate markets. An AI product can be global from day one. Language barriers, which once required separate localized products, can now be handled by translation AI. Cultural differences, which required local expertise, can be learned from data. The entire world becomes your addressable market immediately. Now, we should talk about the risks and limitations, because not everything in the AI scaling story is positive. First, the massive upfront costs mean that only well-funded companies can compete in certain AI domains. Training large language models costs hundreds of millions of dollars. Building autonomous vehicle systems requires billions in investment. This creates oligopoly tendencies where only a handful of companies can afford to compete. Second, the energy consumption of AI is staggering and growing. Training large models requires data centers that consume as much electricity as small cities. As AI scales, so does its environmental footprint. This is a constraint that could limit how fast and how far AI businesses can scale without significant advances in computational efficiency or renewable energy. Third, there's increasing regulatory scrutiny. Governments around the world are waking up to the power and potential dangers of AI. Data privacy regulations like GDPR, AI-specific regulations being proposed in the EU, concerns about algorithmic bias and discrimination, these all create friction that can slow AI business scaling. Unlike the early internet era, when companies could move fast and break things without consequence, AI companies are facing regulatory constraints much earlier in their life cycles. But despite these limitations, the fundamental drivers of AI scaling remain incredibly powerful. The near-zero marginal cost of serving additional users, the data network effects, the automation of human intelligence, the global reach, the investor willingness to fund growth, these factors combine to create scaling dynamics unlike anything we've seen in business history. What's particularly interesting is that we're still in the early stages. The AI businesses we see today, as impressive as their scaling has been, are likely just the beginning. As AI capabilities continue to improve, as infrastructure costs continue to fall, as more industries become penetrated by AI, we'll see even more dramatic examples of rapid scaling. The barriers that have historically limited business growth are falling away, and the businesses that understand and harness these dynamics will reshape the global economy. The real question isn't why AI businesses scale so fast. The mechanisms are clear. The real question is what kind of world we want to build with this scaling power, and whether our institutions, regulations, and social structures can adapt quickly enough to ensure that this unprecedented business scaling translates into broadly shared prosperity rather than concentrated power and wealth. Because one thing is certain, AI businesses will continue to scale at speeds that would have seemed impossible just a decade ago, and that scaling will reshape everything from how we work to how we live, to how economic value is created and distributed in society.